Alright, hopefully you're coming from the last video where we understood everything from point 1 to point 7. In this video, we'll cover everything from point 8 to point 14. Without any further ado, let's start with the very first simplest terminology for today, children. Something like these two cuties over here. The children prop allows you to pass elements or components as props to other components. Very jargony long statement. Let's start with the use case. Let's say I ask you to create a card component. Harkirat, what is a card component? Something like this. I say, dekho agar, if you look at it, there is some text written over here, but it's inside a white card. There is my title here, image here, everything inside a white card. There is my text over here, media, everything is inside various cards. This thing over here has like some special sort of a card which has, this one specifically has some blue area on the top, but every other card that you see is just white text with HTML inside. So can we somehow create a generic card component जिसके अंदर we can pass the internal contents as a prop? ये card component के अंदर this text went, inside the same card component this image went, this title went. When you want to build a use case like this is where the children prop comes into the picture. Let's see this more actionably. We want to create a card component which will have a div outside, and this div has background color white, or let's say our card is a little special, background color black. We are creating slightly different sort of a card. Border radius 10, because if you remember the LinkedIn card right here, there is some radius over here. Here the color is white. The one that we are creating, the background color is black. And what else does this guy have? This guy has, some border, some outline over here, background color. Maybe the color of the text inside is white. I have created this wrapper card component. I have created a card component जो कि बाहर का structure बना रहा है. It is creating the outside structure for all of these cards. And whatever is inside is the dynamic part. Whatever is inside, इसको अंदर ये डालना है. This guy needs to put this inside. This guy needs to put this inside. So I want to take something as an input जो मैं यहाँ पे render कर दूंगा. I will take something as an input here, which I am calling children, which I will simply render inside. The अंदर का मसाला, whatever is coming inside is dynamic. The outer structure is static. Okay, I'm going to create a card. Background color is going to be black for us. For them, it's white. And it is going to have some border radius. So I have created a generic wrapper component. How do I use it? Do I write something like this? Card children equal to some HTML or some React component over here. I can do that. I am saying, okay, hey, children is a prop over here. I will pass children as a prop over here. But this children prop is slightly special. If this was something else, inner content, so this would have been fine. In fact, let me show you. Okay, inner content is, let's say, a div which says hi there. You can pass this. You can pass a React element as a prop to the card component. अभी थोड़ा confusing हो जाएगा. It's sort of like recursion, even though it isn't really recursion. But card is taking another div as an input and rendering it inside the wrapper. This is a wrapper. The contents inside the wrapper are this contents right here that I'm sort of. This content will eventually come over here. So when I pass inner content as a prop over here, that HTML, or if you want to start simple, let me just do this. Okay, our card inner content is hi there. Okay, I've passed in a string that comes in as a prop that gets rendered inside this wrapper div. Let's see what this looks like. Let me get rid of the use state, get rid of everything here. This is working. Localhost :5173. I have a card inside which hi there is written. Of course, ours is a much ugly card. It is very long. Let me, maybe convert this into a span. Then it looks something like this. Let me add a generic padding to the card so that, it looks something like this. Maybe add some margin as well. So this is what the card looks like for us right now. Now the question is this truly a generic card component? And it is. I can add another card right after where I say the inner content is not simply a string, but a div in itself, a React element in itself, where I've written, hello there. And let's say I've changed the contents of this to be, the color here is going to be green for hello there. Now if I look at the final output, it gets messed up because of this being a div, sorry, a span. So let me do something like this, style equal to display flex. I have two cards, card number 1, card number 2. Both of these cards are using this generic card component. That is why they look the same as LinkedIn. LinkedIn पे भी तो ये और ये, they look the same. Inner body is different. Outer wrapping structure is the same. I can make it even more complex. I can add a input box over here. Type equal to, let's say, text, something like this. तो ये जो generic component है मेरा, this generic component now has some text here. For example, what do you want to post? And then let's say we put a BR tag here and another BR tag. This is like the LinkedIn post thingy over here. And then if I want, I can have the other card right next to it, below it, wherever I want. Do we understand what we are doing? I have created a card component जहाँ पे मैंने सारे style डाल दिए. Now style depend on me. I can change the background to be gray. Applies to both of them. I can change the background to be red. Applies to both of them. So my generic card component मैं change कर सकता हूँ अपने हिसाब से. If I turn on dark mode over here, all the cards will start to have black as a background color. So that is why this generic card component is sort of, a lifesaver for us. Okay, I have wrapped the inner contents inside a div. What have I done? क्या ये मेरा parent div है. This parent div has background color red, color as white, some padding over here so that there is some padding here, there is some padding here. I have been able to create a generic card component. For components like these, where you want to wrap inside some outer div, some inner React component, you can use the children prop. Rather than naming this inner content, name it children. Name it children everywhere. And rather than passing children like this, which is very hard to read, if you look at it, children equal to curly braces जिसके अंदर there is so much HTML that is written. Very hard to read. But tell me this, isn't this easy to read? If I write something like this, isn't this much easier to read? क्या जैसे div के अंदर content डालते हैं वैसे card के अंदर I have put some content. I have wrapped my HTML inside the card component. If you look at the card component, what will it do? It will wrap whatever you are passing as children. ये जो children prop यहाँ पे है, this children prop automatically becomes all of this content. All of this content that you're passing in, that thing that I've done over here is the same as me doing card children equal to this thing. So I can either pass it as a children prop, but isn't this much more easier to read? Even for the second guy, can't I just put hi there over here? Isn't this much more readable than, passing in it as a specific prom like inner content? That is why you use the children prop for use cases like these, where you want to create a wrapper component, a component जहाँ पे you want all the kids to get wrapped inside some style. You want all of this content to get wrapped inside a card. Then you will create a generic card component. You will say कि यार I will get some children as an input. मुझे कुछ children मिलेंगे. I will wrap those children inside a div so that they appear inside a card. And that is how these two cards get rendered on the screen. Now you can always make them pretty. Okay, I'm going to make the background color white, color black, and let me change the parent guy's color to be whatever. Background gray. So card number 1, card number 2. And same thing is happening in LinkedIn as well, right? This is a card, this is a card. We have created a generic card component. The special thing is we are passing the props as children. We are not passing the props like this. Can you pass it like this as a prop? You can. React won't stop you. But isn't this much more easier to read? Yes, it is, Harkirat. So just to make it more easier to read, these wrapper components mein, whatever you pass inside this component comes in as a children prop over here, and you can use that. The way I've used that is rendered it right here. Now if I write this, let's say children and then children, what do you think happens? I am passing it some content. That content is coming in this children variable, and I am rendering it twice. So what would happen? This children gets rendered twice. Hi there gets rendered twice over here. What happens if I write upper top bar first, and then I render the children, and then I write lower bottom footer? Then first the top bar comes, then my main content comes, then the bottom bar comes. Same thing over here. First the top bar comes, then my content unfortunately is just a string. Let me convert this into a div. Then again upper top bar comes, then the real content comes, then the lower bottom footer comes. So if you want to wrap some content, what happens on LinkedIn? This is the top bar. On most websites, there will be a footer as well. If you go to app.nextsteps.com, there is a top bar. There is if I go to its landing page, there is a top bar over here. And if I go to the bottom, there is this footer over here that appears. So you can here also create a wrapper component jahan pe pehle top bar is rendered. Then your internal content comes, which can be dynamic. Then the footer is rendered. If I go to the login page, again notice there is a top bar. There is no footer on this page. So this doesn't cover that specific use case, but hopefully you get the idea. If you want to wrap some inner content with some topper and some footer, and it needs to appear on multiple pages, that is similar to what we are doing here, right? There is a top bar, there is a bottom bar, there is some content in the middle. How have we done it? By creating a generic card component. This card component that I have created, let me put in the slides as well. But you will find another card component here. Let me just put mine. This one's probably a prettier one. Let's try that out. Let's try out this pretty card component. Let me just copy the whole thing that we have in the slides. Let's see what it looks like. Can you see it's much prettier? What does the card component have? It has some border as well with some, grayish color. That's solid. That is this border. It has some border radius, 5 pixels. It has some padding, some margin, some box shadow as well, which is what, gives it this shadow right here. Inside which again, children are rendered. Here, card component, and then whatever, title, and then some text over here. Card component, I can add title. I can add a input box if I want. And that gets rendered over here. I can make it a text area if I want. If I want it to be slightly bigger, I can give it full width if I want to create something like this. So wrapper components के लिए just the prop that is being passed is called children. That is it. इसके अंदर जो भी आप pass करोगे, that will automatically come in as the children variable over here. So this children variable will become all of this right here. And wherever you are rendering the children component, which in our case is inside this div, we are rendering the children component. That is what is coming over here. Cool. That is how you do children in React. That is what are children in React. Next up, let's understand lists and keys. Lists, so we have already done. Keys are the concept that we need to understand next. All right. We've understood lists and list rendering until this point. Let's do a quick recap. How can I, remember we did the LinkedIn posts. Let me take another example. Let's say to-dos. Const to-dos equal to a list of to-dos. Let's say title go to gym and done false. And then another one, title eat food and then done, true, something like this. I have done, created an array here. How did we render the array? If you remember, we first created todos components equal to todos.map to do, and here we said here, let's say there is a to do component which takes a title and a done as an input and returns something like this. Title is rendered over here, and then if it is done, then we can render something like done. If it is not done, then please finish, or whatever, maybe a checkbox or something like that. How do you create checkboxes in HTML? Totally forgot, but let's just do not done, something like this. That's how the to do component renders. It first renders the title of the to do. If it is done, then it renders done. If it is not done, then it renders not done on the screen. And here I map this array of objects to an array of components. To do title equal to do.title, and whatever done equal to do.done. And this to do's components is what gets rendered over here, so that if you look at the final website, it has both of your to do's rendered on the screen. The app component has an array of to do's. We convert them to an array of components. We render those components over here. But notice when I click on inspect and go to the console, it will tell you, warning, each child in a list should have a unique key prop. It will also take you to a page where I'll explain. Okay, you will need to give each array item a key, a string or a number that uniquely identifies it amongst the items in the array. Whenever you are rendering a list in React, what are you doing effectively here? Eventually, you will have an array where there will be a to do component, or whatever to do component here, and then there will be another to do component here, something like this. This is what we are doing. So when you are doing this, amongst the many props that you are passing, so could be whatever title. Yeah, you don't even need this. Let's just keep it even simple. Remove all of this. Title equal to go to gym. Done equal to false. Okay. And the second, let's say, element of this array is something similar. Title equal to eat food. Done equal to false. Everything is fine, but you will see this error in the console. It says each child in the list should have a unique key property. It says कि whatever children you are passing in the array needs to have a key which uniquely identifies कि ये कौन सा element है. This is the first element, the second element, or this to do might have an ID. So give it that unique ID, something unique to identify it. Now if I refresh, there are no warnings in here. But if I remove this key attribute, then notice this warning pops up. So even though I'm not using the key attribute here, but still when you are using React and you are rendering a list, you need to pass in a key as an input. This should uniquely identify that specific to do. So when we build a full stack application, you will see this will become the ID of the to do. Whatever is the database ID of the to do, put it over here. If we were creating LinkedIn, then it would just be the post ID here. Okay, post 1 ID, post 2 ID, post 3 ID. RIP sir, what a journey. And God did he look handsome in his youth. All right. To whatever the post ID is, so on and so forth. So this key is something you have to pass. You can ignore passing it and you can not pass it. It's just a warning. But this is one common, very common interview question. And two, in some cases, you will see weird rendering issues. This will also lead to some performance downsides. React will not be able to understand if this array ever changes. If this array goes from, let's say the state changes, let's say this array was a state variable and then the state changed to something like this. They got flipped somehow. So now React understands कि अच्छा जिसकी key 2 थी that went up, जिसकी key 1 थी that came down. So React can figure out the differences really well if you are giving every to do or every individual component here a key. If you don't give every individual element here a key, what would happen is React would not know that the flip has happened. The original to do that was here went here, that was here went here. So it will probably just remove both the elements, re-add both the elements. But if it understands कि अच्छा ये तो flip ही हुए हैं, so it will just remove this element from DOM and reinsert it afterwards. It can do that performance optimization. अगर आप उसको बता रहे हो कि भाई this is the element with key 2, this is the element with key 1. If you are not telling it कि यार this is the element with key 2 and key 1, and then you flip both of them, तो React wouldn't know कि अच्छा यार ये वही वाला है. It's not like it's maintaining अच्छा ये title और ये description वाला was first below and then above. It says कि मुझे key दे दो, upfront ही बता दो. Tell me upfront कि this one has ID 1, this one has ID 2. So that if you ever do this, if there is a re-render that happens that causes them to flip, then I can do some optimizations and I can make sure कि मैं ऊपर वाला निकाल दूँ. I will delete this from the DOM and reinsert it over here, rather than removing both the elements and then reinserting both the elements one after the other. So this key attribute is used by React to identify yeah, this is 2 to 1, this is 2 to 2, this is 2 to 3. They should always be unique. If you give it the same key, that is also problematic. Make sure, as you can see, it says encountered 2 children with the same key 1. Keys should be unique so that component maintains their identity across updates. Across re-renders. These individual components should maintain their identity. If this was 2 abhi and across a re-render, this sort of, let's say, got deleted. So React should know that the to do with ID 2 has been deleted. I need to remove it from here. So that is why, if you, can you see some problem already here? This happened because of hot module reloading. But if you look at it, React is nothing special, especially for lists. If you give it keys, it will become very wonky if you have given it the same key twice. It will start to assume कि अच्छा ये भी वही है, ये भी वही है. It will not understand. And as you can see now, even though I have a single to do here, you see 2 of them on screen. So whenever you are doing lists, make sure you are passing in a key which is unique. Usually when you are doing a list, you are rendering something like LinkedIn posts. So in that case, you already know the post ID of this is what I'm going to render. The post ID of this is what I'm going to give as the key. So the key for this will be is key post ID, whatever is the ID in the database. Key for this will be whatever is the ID of this in the database. That for sure is always going to be unique. Cool. That is how you do lists, which sort of you already knew. Keys is something new that we learned today. And how did we learn key? Why do you need keys? If you don't use keys, number 1, there will be performance downsides. Number 2, you will have this red error in your console always. And number 3, in some cases, you will see inconsistencies also. Okay, the front end is showing something that does not appear in the React code. That is what are lists and keys. Next up, we'll understand inline styling. All right, we've already done this many times. Hopefully you already know this by now. If you want to give inline styles to div, what do I mean when I say inline styles? कि जहाँ पे div defined है, right next to it you give it the styles, then you give it in an object that is passed inside the curly braces. So if I copy this, open Visual Studio Code, and let's say replace to do with my component and render my component over here, then this hello world will be inside a div which has some background color and some text color. So if I open this right here and refresh, you will see hello the world is printed on the screen with some blue color behind. And if I change this to red, then as you can guess, the background color becomes red. So the only complicated thing here is double curly braces, which people get confused with, which, as I've mentioned before, the idea is that you are defining the style in an object and you are passing that style object here. You can name this whatever you want, whatever component styles. And when I refresh this, these styles are what are getting applied to this div. Now, color white, background color red is what appears over here right now. If I want, I can add padding, border radius, and all those styles would appear over here. This is slightly unlike how we have done styles until now. If you remember in our HTML journey, this is how we did styles, background, color, red. This is how we did inline styles back then. But in case of React, since this isn't really a div element, this is like an XML element that React DOM render understands. This isn't really a div element. It just appears like it when you're writing React. So that is why, you have to pass styles as an object, which you can pass either by separately defining it or by passing it in like this. Cool. The only difficult bit, ये double braces क्यों है? And the double braces का reason is कि the thing inside is an object, and we have seen until now, whenever you are passing props, you first wrap it inside single curly braces. Cool. That is all I have for inline styles. Eventually we will be learning Tailwind, where styling is a whole different ball game. We'll understand how you do styles using Tailwind. Most projects you will see or write yourself, you will be using Tailwind yourself. Let's move on to popular interview question. Not something you have to deal with for a while, but let's understand class-based components and how are they different from functional components. All right, now we're going to understand a mildly legacy concept. Until now, the components that we have written are called functional components, but there is actually another way to write components in React called class-based components. That is what we're learning today. Do you need them? No. Rarely do code bases use them. For example, this was one example I used to give to everyone. Okay, this specific React project still uses class-based components, but they also had an open issue: convert legacy React class components into the new functional components. And this is a closed issue now, which means they have also migrated to the functional components, same thing that we have been writing until now. But until, some 2017, 18, 19, whatever that date was, class-based components were the only way to create React components. They've slowly been, I wouldn't say depreciated, but no one uses them. Everyone uses this. This is what we have learned. Just for an interview question, let's understand how class-based components look like. Earlier, React components were written using class-based components. Slowly, functional components were introduced, and today they're the ones you'll see everywhere. Class-based components are classes that extend another class called React.component, while functional components are simple functions that can use hooks inside them. This is what your counter component would look like. If you are using the legacy class-based component, you would define a class called class counter, let's say, which extends React.component, a component that is exported over here. This is another class. This is how you would define the state. This is how you would define functions like an increment function. And you would have another function called render, where you would return your final div. So looks very similar to how we've written, right? This is how the functional component looks like. We had a state variable defined using the useState hook. Here the state variable is defined directly over here as a sister object to this class, or whatever, sister attribute to an object of this class. Here, this is how we define a function, simply how you define a function inside a function. Here again, it is another attribute. Simply return this div from this function. And here we have a render function which returns this div. So functional components versus class-based components, that is the difference. If you compare them, you can use either, doesn't matter. You can still use the class-based component. Let me show you. Let me copy over this class-based component and replace it over here. Take this import, put it on the top, and over here let me render the class counter, which again, class counter extends component. This is the state, this is the increment function, this is the render function. If I go here to localhost:5173, there's some error. Let's see what the error is. Oh, I've imported React twice. Refresh. There you go. Increment still works. So there's nothing out of the ordinary that this guy does. Whatever can be done using class-based components can today be done using functional components. Whatever can be done using functional components can be done using class-based components. This is much harder to read, a very different way to maintain state over here. And update state, this is how you update state. You call this dot set state. You call this dot set state, and there is a global, not a global, but like a state object at the top. यहाँ पे you can in our class-based components, sorry, functional components, you can define multiple state variables. Here there is a global state attribute for this counter. Here is where you have to define all of your state variables. If you had to-dos, you would define them over here. If you had something else, you would define that over here. And this is how you would update the state. Versus in our functional components, we just call the set count function, for example, the set count function to increase the count. Overall, this is how you do state and initialization in functional components. This is how you do state initialization in class-based components. This is how you define a function here, define a function here, return some HTML, return some HTML. Cool. Hopefully that is simple enough. That's how functional components and class-based components are different from each other. Do we ever use this? No. Was this the norm before in React? Yes, this was the only way to create components. Slowly this became much more adopted. Now everyone uses this. This has sort of become legacy. All right. You can't use hooks over here. Use state has no concept over here. Use state, use effect were all meant for functional components. None of this is meant for class-based components. You will never have to write this now, thankfully. In a new project, so for sure, if you write it, it's a red flag. But in an old project, legacy project, you might look at it and then, you will have to pattern match and understand ki acha, state initialization, defining functions and rendering the final component. Cool. That's all for class-based components versus functional components. Next up, let's understand lifecycle events, which was like a proper thing in class-based components and something we sort of, do in a very ad hoc way in functional components. Let's get into that next. All right, let's understand lifecycle events next. We've sort of done this once for functional components. We didn't really give it a name though. So today, let's understand how they work in class-based components and their equivalent in functional components. In React, lifecycle events refer to specific points in a component's life where you can execute code in response to changes or action. These events help you manage tasks such as data fetching, subscription, cleaning up resources. Have we seen this in the past? Does this give us deja vu of use effects? Class-based component lifecycle methods are methods that let you hook into, refer specific points in a component's lifecycle. What is it? Lifecycle event. When was the component mounted? That is a lifecycle event. When was the component unmounted? That is a lifecycle event. So this component that we have written could be a class-based component, could be a functional component, doesn't matter. How can I hook into its life cycle events? For our functional component, we already understand. If I want to hook into, whenever this count variable changes, I want some code to run. I can create a use effect, give it count as a dependency. This code will run every time the count variable changes. For this use effect that we have right here, since the dependency array is empty, this code will run when the component mounts. This is me hooking into the lifecycle events. This is the mounting lifecycle event. This is the unmounting lifecycle event. If I copy this, if I go to whatever my component over here, if I render this my component, you will see the component mounted log will come on the screen right now, and the component mounted or count updated log will come on the screen. If I open localhost :5173, notice what logs come. Component mounted or count updated came, this log right here, and component mounted, this log right here came, because these are the two effects that are running in response to the component mounting, the count variable getting initialized. Now every time I increase the count variable, what happens when I click on the button? Set count, count +1, or if you want to get fancy, then the arrow function syntax that we had written. In this case, this will also work. So when I click on increment, component mounted or count updated gets rendered, because I haven't really hooked into a lifecycle event. I wouldn't call this a lifecycle event. A lifecycle event is more like component mounted, component updated, component unmounted. This is more like the count variable updated. So I wouldn't call this a lifecycle event. Nonetheless, you understand, if I want to hook into a variable changing this specific event and run some logic on top, then I can do that by using the use effect hook in functional components. And more specifically, if I really want to hook into just the lifecycle events, which is the most important thing, which is what you will be doing most of the times, then this dependency array is empty. The dependency array that you pass is empty. And then all the code that is put over here, that code will run on mount. All the code that is put over here, that code will run on unmount. That is already something that we can see if I refresh. Component mounted gets rendered. If I write the code over here to unmount this specific component, we have done this in the past. Hopefully you can do that by now. If I write the code at some sort of a, state variable const is component shown, comma, set is component shown equal to use state true. And then I conditionally render this is component shown, then render this. Then what will happen is, if I change the state variable, let's say every 5 seconds, then this will get unmounted. And whenever this gets unmounted, you will see component will unmount gets rendered on the screen. Cool. These are how you hook into lifecycle events in a functional component, and something we have already done, something you would be doing in your life usually. Now, if you want to see how this used to happen in legacy class-based components, here is how it used to happen. When you would define your component like this class, whatever the name of the class is, extends react.component, constructor के अंदर you would initialize the state. You could override a function from this react.component class called component did mount, and यहाँ पे जो भी आप logic लिखते, whatever logic you would write here would run when the component mounts. Similarly, component will unmount. Whatever logic you would write over here would run when the component would unmount. And another one was component did update. Anytime the state changed or anytime the props to this specific component changed, the props or the state changed, then this component did update would trigger. This is like a use effect only, but the dependency is everything in the state and everything in the props. When that becomes a dependency, component did mount comes into the picture. And here you can find कि अच्छा क्या change हुआ है? Is the tab changed? Do I need to refetch something from the notifications tab like we did in the last video? If you remember, we were doing something like we created a simple tab interface where I could go from one tab to another tab to another tab. And we were storing this in a state variable. And whenever this state variable would change, I would send a backend request. The same thing you can do over here. Only thing is you will have to check okay, what was the previous state and what is the current state by running, whatever this dot state, and then compare ke, has the tab changed? If the tab has changed, then refetch things from the backend. So this is how you would hook into lifecycle events in the existing old class-based components. Do you need to worry about it? Thankfully not. No one writes code like this, but the term lifecycle components lifecycle of components or lifecycle events, was introduced in class-based components. And thankfully today in functional components also, you can do everything that can be done over here. You can run some code when the component mounts. You can run some code when the component unmounts. You can run some code whenever the component changes. The same thing I'm doing over here, running some code when the count variable changes, running some code when the component mounts, running some code when the component unmounts. That is what are life cycle events in React. You don't need to know this term anymore, not very relevant after, class-based components went away, not really used as such. As long as you understand use effects, when to use them, you're good to go. You don't need to know the term, but it's good to know the term for, interview preparation. If some old person who's, only used class-based component has this as an interview question, you should be able to respond. With that, we will move on to error boundary, again, some slightly legacy thing. And the reason I've introduced it here is because this is where you unfortunately have to use a class-based component only. So I used to work at this very big company, and throughout the code base, there was just one class-based component. That's when I went down this rabbit hole of error boundary and how, this one thing is something you can't do with functional components yet. You have to use class-based components for this. Let's understand this next. All right. For this next thing that we're learning, error boundaries, let me take you through, one real use case where I saw it in actuality. One day I was on this YouTube dashboard and I saw everything else is working correct. But this specific card that you see over here, that showed me sorry, there is an error, and there was a button to refresh. I tried refreshing a few times, it did not fix it. But that is the first time where, on a big website, I finally saw that error boundaries are being used the right way. The name itself is error boundary. It lets you contain errors, and hence it is called an error boundary. What happens is, it might happen that some API request over here is failing, or some API request in this card is failing. So when that happens, you don't want your complete application to crash. You only want this specific thing to fall back to a component that says, sorry, this data cannot be loaded. You don't want your complete application to crash. That is where error boundary comes into the picture. As the name suggests, it lets you bound an error. कि यार इसके बाहर नहीं जाएगा error. If there is an error here, that's fine. We will fall back to some other UI here, but we will not let the error propagate to the full website. We don't want the website to crash. Let's try to simulate something like this and recreate something similar to what I saw here. Let's try to create two cards over here. So let me get rid of everything. Let me create, function card1 and then function card2. Inside the first card, let me return something like div hi there and add some style to it. Background red, border radius 20. And then the same thing over here where let's say I write hello. All right, I have two cards. Let me render both of the cards here. Card 1 and card 2. They sort of look ugly, so let me add some padding. Something like this. We have two cards over here. Now, let's say one of these cards has an exception. Inside a use effect, you send some backend request. We'll be doing this eventually. Eventually, when we create a full stack application, inside a use effect, we'll be sending a fetch request, which might fail, let's say. Or if you want, you can just throw a new error inside this component, error while rendering. And you will see your complete website will crash. If I comment this line, then we're good to go. If I uncomment this line, if I throw an error in the first card, then the application breaks. But the error was just in the first card. Why can't we contain the error right there? Why do we have to make the complete website go down? As I said a while back, the thing that happened when I was on this page was this card sort of broke. And here I saw whatever, the UI is down, please press XYZ button to refresh this specific card. Why can't I do something like this? Why can't I have a fallback UI for card 1? Okay, if there is an error here, fall back to a different card. That is what error boundaries let you do. Error boundaries are React components that catch JavaScript errors in their child component and display a fallback UI. That is exactly what we want. We want to show a fallback UI if there is an error in our, let's say, card 1 component. The way it works is you have to first define an error boundary class-based component. As I said, this doesn't work in functional components right now. The only reason you might have to use a class-based component, and also feel free to use it as a black box, is that this specific class-based component you need to understand a little bit, but at the very least use. What is this error boundary component? The constructor does nothing. It just sets the state to be has error false. And this specific function, the get derived state from error function, is a function that gets called if any of the child throws an error, and this updates the state to be has error true. And if you look at it in the render function, I say if there is an error, then render this fallback UI, else render this dot props dot children. Do we remember children? Yes, Harkirat. In class-based components, the way you get props is this dot props dot whatever the name of the prop is. In our case, we want, if I am wrapping this card component inside the error boundary component, if I am wrapping this card component inside the error boundary component, error boundary component will get this card as the children prop, and that is what it should render unless the error has been thrown. Agar error throw ho gaya, then show the fallback UI. Error has not been thrown, show the original UI. Let's see this in action. Let me copy this class, and you can paste it here. You can move it to a separate file, whatever is comfortable to you. Let me just paste it here. File has become a little bit bigger. So you can also put it in a separate file and export it from here. React is imported. React.component will be available. Let's see what the UI looks like right now. Can you see there is a fallback UI that appears because I've wrapped this card inside an error boundary, and in the error boundary I have said that if you look at the render function, if an error has been thrown, then show the fallback UI, else show the original UI. So if I don't throw an error in this card1 component, then original card comes. But if there is ever an error thrown, my complete app doesn't crash. Just this part fallbacks to a separate card. And ideally, this fallback UI should also look something like the same card. The fallback UI should do something like this. Something went wrong. So that if it crashes also, UI wise it looks the same. Of course, the message inside changes. Okay, something went wrong. Please try again later, or whatever, refresh your page. So that is what an error boundary is. As I said, you can also take this as a black box, by which I mean, copy paste this into your very big code base, because that is what most companies do. Look at any open source code base of any company I've worked at, or even the closed source company, code bases before. This is sort of a black box that is introduced, and anytime there is a crash, this fallback UI is what renders on the screen. If there is not a crash, then the original thing renders on the screen. Cool. That is what the error boundary is, and super useful or super needed in a mobile app, because mobile apps crash a lot, or components there crash a lot. So over there, you should have error boundaries to make sure the app doesn't crash. It's a very bad experience if the app crashes, and very hard to update the app also. So over there, this matters a little too much. If you are writing React Native code, there is heavy emphasis on error boundaries. Websites may, number one, the number of times the error is thrown is lower, and number two, if it is thrown, it's easier to fix and deploy it to a website, much harder to deploy it on a mobile app. So you will see this much more in React Native, but here also, always a good idea to wrap your components that can throw an error in an error boundary. Right now, what will happen is I have not wrapped card2 inside the error boundary. So if card2 crashes, then the website will still crash. As you can see, website crashed. But if I wrap card2 inside an error boundary also, then the error over there will also get caught, and both of them will fall back to the other UI. Cool. That is what error boundary is. Next up, we're going to understand the last concept for today, which is fragments in React. All right. One very important sort of mistake you will see all beginners make in React is, they'll always get confused by this, is they will try to return something like this. Here I have a div and then another div right next to it. Here I've written hi there. Here I've written hello. But as you can see, the React compiler is sort of complaining over here. Is this easy to understand from first principles? I can never return this to from a function. If this is a function, okay, this syntax might feel weird. So let me write it like this. This is a function that I have described over here. I can't return 2 space 2 from it. I can't return a string and then another string from it. I can only return a single string, right? Or a single number. So similarly, I can't be like return first div hi there, and then I'm going to have a second child div which will have hello right next to it. You can't return two things from a div. Sometimes you will try to wrap this inside a round basis. Here this might work, but here also the problem remains the same. React expects whatever function you are whatever function is returning some content, it should return a single top level div. अंदर आपको जितने बच्चे डालने डाल लो. Put as many children you want inside, but there should be a single top level div, span, or something else that wraps all the children. You can never return something like this. React will begin to complain. JSX expressions must have one parent element. We have two elements. कह रहा है इनको एक parent में डाल दो. JSX elements must have one parent element जिसके अंदर we have two children right next to each other right now. So this is just one thing to know. And whenever you are seeing this error, what are you going to do? Simple, wrap your whole application or this specific component inside a div and you are good to go. Error gone. If you look at the final code or the final website, it looks right. If I remove this top level parent, then of course there is a problem. This is great and good enough. Most of the times you would just do this and forget. But there is one small problem here. I have introduced an extra div. If you look at the final structure here, what if I wanted कि जो मेरा React container है, whatever is my React container, let's see if I go to elements, do I make this smaller? There you go. This div ID equal to root. This is my React container. I wanted two children inside, child 1, child 2. I do not want a parent div which gets two div insides, even though it makes no difference in the UI. UI still looks the same. But you are very adamant. Okay, I don't want this. I don't want this extra div here. The root div itself should have two children, Harkirat. So in that case, you can use fragments in React, which basically is something like this. Okay, rather than putting div or a span, don't put anything inside. Just write a empty opening braces, empty closing braces. And if you look at it now, div ID equal to root indeed has two direct children. I did not have to introduce an extra div over here inside which we have two children. I have sort of gotten rid of these extra, extra one div parent over here, even though no real difference in the UI, but still, just for kicks, if you feel like it, if you want to get rid of one extra div over here, you can by using React fragments, which you can use like this, or you can also import fragment from React and put fragment and /fragment over here. It would do the same thing. So either import fragment from React and wrap your app like this, or no need to import fragment from React. Opening empty tag, closing empty tag would do the same thing. UI wise, nothing changed. But if I put a div over here and /div over here, then you will see that extra wrapper div in the final output. You will see first a div inside which child 1 and child 2, rather than, this. All right. That is what are fragments in React. Let's go through the slides also. In React, a component can return a single parent element, but it can contain multiple children within the single parent. So this code is wrong and this code is right. And we are using React fragments over here. You can also use a div. On the UI, you see nothing different, but of course you can get rid of one extra layer of nesting if you use a React fragment rather than using a div. Cool. That is what are fragments in React, and that covers probably some basic foundations for React. We'll understand single page applications, layouts, and building a website during the live class. Then we will go into some complex state management. We will understand rolling the state to the top of the application. Then we will understand context API. We'll understand prop drilling. And then lastly, we will go to some framework for doing state management. We will see which one. Recoil, Redux, the third one that's popular. Skipping my head right now. There's one called MobX, I think. And then there's one more. State management libraries in React. There are like many of them. We've only used Recoil until now. Um, but let's see what are the top 7. Redux, ZooStan was the one that I was talking about, and then there's MobX and there's Recoil. So we'll see which one of these we pick and try to understand. All right. With that, let's end it, folks. I will see you guys in the live class next, where we understand these 3 concepts.